blade server is basically a small form factor computer that there are many vendors that sell different blade chassis that accept different models of blade servers, and what it lets you do is consolidate your resources in a smaller space so you can increase the computational density in your machine room. It also adds some monitoring, some out-of-band monitoring functionality that's available in other formats, but it's really simple to put into this form factor. And potentially it will allow you to reduce the costs of the sort of IT infrastructure you're purchasing, because you can use that chassis that those blades are going in. I showed you that thing. Maybe for 5-10 years possibly. So when the blade becomes obsolete, you buy a new one, put it in the same slot, and keep using the same chassis. Chassis that accepts these smaller form factor blades. The chassis deals with the I/O in and out of the blade. For example, the system I showed you back there, all 14 blades in a given chassis share an Ethernet bus on the back of the chassis. There's an Ethernet switch in the chassis, so all the networking is consolidated. The chassis, the blades themselves, don't accept Ethernet jacks, cables, that sort of thing. And then the chassis will have a management module as well that will allow you to monitor temperature, power utilization, that sort of thing, and shut blades down and bring them back online remotely. So how it works, in a sense, is it sort of differentiates some of the functionality in a standard computer, pulls it out, puts it in another place so that you can do things more effectively, more efficiently. We use them when we need high-density computing. When I started here, we had a lot of what I would call 2, 3, 4U computers, and by U I mean the sort of spaces in a rack. Mm-hmm. Big boxes. They've got large hard drives or several hard drives, that sort of thing, and maybe 1 or 2 processors. So the space that a couple of those older machines would take, and then only give you maybe 4 CPUs and a certain amount of disk, we can put on the order of 50 processors in that same physical space. So you're really reducing the amount of floor space you need to have a given amount of computational power or memory, that sort of thing. So it's effective if you're restricted with. Yeah, now I'm from the research group. I really can't speak to across the university as a whole. And even UITS, I'm not clear on how many groups are using blades, although I know, all the vendors, serious vendors, IBM, HP, and SGI, they all offer blade solutions, so it's quite possible that there's a lot more back there than I've seen. There's a lot of computers back there. I don't make it a point to wander around and poke about, but everything I've told you so far about density is particularly important in the field I'm in, which is research, high-performance computing. There are a lot of problems that researchers are trying to solve that require scores or hundreds or sometimes even thousands of processors. So if you need 1,000 processors, and it's going to take less area to install those processors, I mean less floor space, in a blade system than it does in a traditional 1 or 2U system. You might lean towards that blade system just because you don't have to have, you can get by with 20 racks, like we saw back there, instead of 100 racks. This is the upside of blades. Downside, like I mentioned to you, is the heat output per square foot goes up, and so now you've got to figure out how to cool your room down. Drive. You can put 2 drives in, but we've removed 1 drive and put this special network card in. You know what gigabit Ethernet is? Everybody's got it. This is called MirrorNet, and what it is it's about twice the bandwidth as gigabit Ethernet, and it's much lower latency. The time it takes for a message to get from here to another node is about a tenth the time it takes on Ethernet. So it's for scientific computing. Researchers want. So but that's everything in here, with the exception of this, is in your desktop machine.